Hi and welcome to the Open Tech Lab. So in today's video I have this big box to unpack. This is the kit for the Anet A8 3D printer, which is a really interesting device to me. It's very low cost. It's available for less than $200 from Chinese sellers. And it's based on an open hardware platform, the RepRap Prusa i3. And there are a few Chinese clones and kits of the Prusa i3 that are available. But the Anet A8 has a certain amount of fame within the community, or one might even say infamy. Within the 3D printing community, it's not considered generally to be a very good kit. It's known to have quite a few problems out of the box, and so a lot of people don't recommend it. But I'm interested in it all the same. It's very, very low cost. And it makes me wonder whether we can get some good results from it. Certainly I've heard reports that people who've persevered with it and have made various modifications have been able to produce some really, really good quality 3D printed objects despite the many problems that it has. So in this video I'm going to be unpacking the kit and assembling it, and we'll have a little test it out and see how it does, and we'll see what options there are for improving its performance overall. So let's get started. So I've unloaded the box and you can see we've got 3 polystyrene trays of interesting looking components, but the thing that really matters to begin with is this little micro SD card reader that contains the instructions. Now if we have a look at the contents of the card, you can see there's a few things here. There's a folder of Windows software including Cura, which is open source model slicing software, and Repetier Host, which is freeware for controlling 3D printers. Then we have a small collection of STL models, and within the collection, strangely enough, there is a bust of Shia LaBeouf. But most importantly of all, we have a folder of PDFs, including the operating manual, a print quality troubleshooting guide, and the assembly instructions. Now the assembly manual looks pretty straightforward. It's completely pictorial, and there are 27 steps in all, and in amongst it there is some amusing Chinese to English translation. Now to make things a bit easier, they've provided a small toolkit. Now all of these tools are pretty cheapo, particularly this spanner, but these side cutters aren't too bad, and it's quite useful having a throwaway pair that you can use for various things. Now I have heard that the 3D printer has a nasty habit of rattling itself to pieces because none of the nuts are locked, and so I've bought myself a packet of Loctite blue thread lock, which I will be using when I assemble it. Now I'm just going through the nuts and bolts here because I've heard a war story from a guy who claims he was sent a packet of nuts that weren't threaded. But all of mine seem to be threaded okay, so we seem to be off to a good start. So anyway, I'm ready to get started, so when I've assembled this thing, I will report back with my reflections. Oh dear, my friends, look at this sorry mess. Oh dear. So I was assembling the unit late last night, and I got through to about step 6 in the assembly instructions, and things were going pretty well, and the unit was going together, but I come back this morning and find that the unit has cracked at almost every point where there is a screw connection. Basically the whole thing's pulled itself to pieces. Now why did this happen? Well, I think there are a couple of factors. One is that the frame material is made of acrylic, and of course acrylic is a very brittle material, and so trying to tighten screws into it is a thing that's going to cause it to crack and break. But also my usage of Loctite blue, reading the manual, it looks that this Loctite will actually react with the plastic, and so potentially will weaken it, which probably played a major factor in causing this thing to crack. And in my defense, I did get this as a recommendation from someone else on the Reddit 3D printing forum, so it wasn't completely my own stupid idea. And of course half the audience out there will probably be face palming at me because everyone knows probably that this Loctite reacts with plastic, but I didn't know. But now I do know. I've learned a lesson the hard way. Anyway, I'm in the process of digging around to see what we can do to salvage the situation. I'm getting a lot of help on the Reddit 3D printing forum. People are being very, very helpful with various suggestions. So let's have a look at what we can do about this. So let's have a closer look at what's actually gone wrong here. So here we've got this little bracket, and the bracket holds this pulley wheel, and the job of the pulley wheel is to hold on to a little belt that pulls the carriage along. Now, as we look around the side here, you can see that we've got the nut and the bolt here, and the nut has basically completely pulled out the bottom half of this acrylic, and so it's broken in half. Now, when I was tightening these nuts and bolts, I only tightened it up to a sort of medium hand-tight level. I certainly didn't use a ratchet or any excessive force or anything, because I was worried about the brittleness of the acrylic. So I'm trying to figure out to what extent this was caused by the brittleness of the acrylic material, and to what extent it was down to my use of Loctite. And I really think that the Loctite must have had some contribution to the problem, because if the brittleness of the acrylic had been that severe, I'm not sure that anyone out there would have successfully assembled this 3D printer, and I have seen that many people have, although the brittleness is a problem. But I think, yes, it is down to me using the Loctite, and I think that made things a lot worse. Now, for a replacement, a few different options have been suggested to me, but I've decided to go with this item. This kit is basically a direct drop-in replacement for the standard frame, but it's made of engineered wood fiberboard laminated with melamine. And this material is going to be a much tougher material, much less brittle, so hopefully it will be better than the original. But it's no better in terms of its structure, and the original does have some issues where it could have some wobbliness to it that could do with some reinforcements. So I'll still have to do something about that later on. So anyway, I've put in my order, so all I have to do now is wait a few days for the delivery to arrive. Well, here we are. My package of parts has been delivered, so we are back in business. Okay, so I'm almost ready to start assembling this thing again, but before we get to that, I've still got to figure out what to do about this nut locking problem. And after the disaster with the Loctite, I'm beginning to get rather disenamored with Loctite gunk as a solution to this problem. And so I think I'd rather proceed with these Nylock locking nuts, and they will hold on nicely, and they don't involve any type of glues or anything. Not that there will be a problem, because this is engineered wood, not plastic, but still, I think it's probably better to be using these. The only problem I have is that these holes in here, these little chambers for these captive nuts to go inside, they're slightly too small for a Nylock nut, which is a bit longer than a standard nut, so I'm going to have to go ahead and file this slot out a little bit to give myself a little bit more space. Now, some of you might be thinking that I'm getting a bit silly and obsessive with this nut locking problem, that I'm making life way too hard for myself, and those people may well be right. Okay, so that's that done. The Nylocks are fitting snugly, so now I'm ready to go back to doing the assembly again. Well, here we are, and as you can see, I've made quite a bit of progress, and we're basically at the point now where I've gone as far with the instructions as I can, but I've got one or two problems still to solve. And as you can see, the electronics is hanging off the back, and the reason for this is that the replacement frame is missing some of the mounting holes that I need to be able to attach it. And there are one or two other mechanical issues that I need to solve. But my thinking is that if I can get the 3D printer to do a basic print, then a lot of the mechanical issues I have, I can print my way out of by printing various replacement parts. And the good news is that all four motors are working, the extruder and the X, Y and Z motors. So hopefully we should be able to get this thing to limp through an initial print of some kind. Now, before moving on, I should say that one of the most major complaints about this kit is that it has one or two quite serious electrical safety issues. And the most well-known of these issues is in regard to the current handling capacity of these connectors. Now, on earlier revisions of this board, this middle connector, the hot end connector, was the same connector used for both the power input and for the heated bed connections. And this type of connector does not have the current handling capacity to be able to safely transfer the current through these connectors. And so several people have posted online various pictures of melted connectors and fire damaged connectors. Now, later revisions of the board, like this one, seem to have replaced the power input and the heat bed connectors with these screw terminals, which seem to have a higher current handling capacity. But you still have to be very careful with these, because if you don't screw these wires in exactly perfectly, you still get a lot of heat generated from the resistance. So you have to be very careful to make sure these screw heads are tightened down nicely. And another thing I noticed while tightening these screws up is that I was very easily able to twist the whole connector around. So the pins that are going down into the PCB really can't be very thick. And this itself is very, very worrying. So I'm not sure that this is as sturdy and solid as I'd really like it to be. Now, I've been monitoring the connections quite carefully to see if I can sense any presence of heat being generated in these screw terminals. And so far, I haven't seen anything that really concerns me. But I would be a lot happier if these screw terminals were a lot more sturdy. Now, the standard way to resolve this issue is to remove the high current from this board entirely. And so to do this, many people have been using an external board with a MOSFET on it, and that big MOSFET will do the main current switching, so that this board only has to handle a tiny current, the switching current, to drive the MOSFET. And that seems to be quite a satisfactory solution in many ways. And I'm quite tempted to get a MOSFET of my own, but so far I'm not convinced that it's going to be necessary in my case. But if you're not sure about this, make sure you do upgrade to a MOSFET, because electrical safety is really important. I wouldn't want you to cause an accident. Now, one particular challenge I've been facing is the positioning of these end-stop switches. And these switches are used so that the printer knows when it comes to the end of its direction of travel. This is called the home position. And when it's in the home position, it knows that the datum position for the bed surface in the corner is a certain number of steps, a certain millimeters offset from that home position. And this offset is hard-coded in the firmware, and therefore it's important that these switches be exactly where they should be. Otherwise the printer will go in the wrong direction to get the print head onto the bed surface. And so the solution I've got here is that I've just hot melt glued the switch onto some scrap bits of acrylic, which I've then hot melt glued onto the side of the frame. And this seems to work okay. In the end, hopefully I'll be able to 3D print something a bit nicer to attach the switch to. Okay, so before we can print anything, we need to prepare the print bed. And with the Anet A8, the intended method of the print bed preparation is to cover it in a layer of fat masking tape that they provide. So you lay down strips of masking tape, and then the printer goes ahead and prints the first layer on top of that surface of tape. Now, to me, that seems completely unsatisfactory, because I really don't want to be laying out strips of tape, you know, making sure they're ever so perfectly level with no bubbles under the stickiness and no overlap between the different strips of tape. That sounds really just not nice to use at all. So one recommendation I've received is to install a glass sheet on top. Now, I ordered this from Amazon for about $12, and what we can do is we can just lay this on top of here and then clip it in place with some of these clips. And the standard trick with glass printing is to spray a coating of hairspray, or in this case I've got some adhesive spray. We can squirt the surface with this spray, and then hopefully the printed object should stick to the glass during the print, but then once the print is completed, the object will pop right off. So for a first test, I've got this calibration cube loaded up in Cura, and this model is pretty small. It's 20 by 20 by 20 millimeters, and it's going to take just over an hour to print. But hopefully if we print this thing out, we should be able to get an idea of how well my version of the printer is performing at this point. Well, as you can see, so far the printer seems to be doing a reasonably good job, which is pretty amazing considering where we've come from on this project. And as you can see, we're about 2/3 of the way through the print, and we're printing out the lattice structure inside the cube. And so we'll wait till it's finished and then see what the final object looks like. Well, here we are. As you can see, the print has completed and we have ourselves a calibration cube. And I must say, I am really impressed with the results. All things considered, this is a fantastic first print. And well, I couldn't really ask for more. It's not perfect, but it's certainly a lot better than I was expecting. So now let's get this thing under the microscope and have a closer look at what the results are like. So to begin with, we're looking at the top Z face of the cube, and as you can see, the results are absolutely fantastic. I have no complaints at all about this face. The outcome looks great. Now, as we go from the best face to the worst, let's have a look at the X face. Now, we've got a few different problems in play here. I think the most significant of these problems is that this is a bit of a step here. So I think the X-axis motor might have lost a step somewhere along the way because the whole top of the cube is offset slightly to the base. That's pretty ugly. Also, you can see we've got one or two problems with vibration. So as the print head changed direction to go into the X lettering here and came out, it came away with a certain amount of vibration, which has caused this slight wobbliness in the surface that you can see here, and it's just, you can see like a certain ringing that comes away from the lettering. So we'll need to do something to try and dampen the vibration down. And also I got a bit of junk printed into my plastic here. So yes, that's not perfect, but as I say, for a first print, I'm really impressed with this. And I think with one or two upgrades, we can get a lot of these problems ironed out. So given that the X face of my cube was the worst of all, it makes sense to me to upgrade the X-axis machinery first of all. And it's no wonder that I was getting some problems with the X-axis, because it's very hard to get the amount of tension into the belt that's really necessary. And that's because the standard way of attaching the belt in the kit is to have these two bolts that are screwed in here, and then you have these cable ties that tie the belt together as it wraps around those bolt heads. And it's really hard to assemble this. You need like 3 or 4 hands to hold the whole lot together while you cable tie it. And then if you manage to get it together with even some tension, after a while the belt may relax a little bit, and so it will loosen off. So we really need a better way of attaching the belt to the carriage, and we also need something that we can use to tension it so we can tighten it up nicely. So first of all, I'm going to print out this belt holder by the user Kenneth Jiang, and I'll link all the upgrade models I use in the show notes. So here we have the model printed out, and as you can see, the results on this side are looking pretty good. There are no steps in it this time, which is really good. The only issue is on the base layer, which is looking a bit like a bird's nest, and that's because the filament didn't stick to the glass plate very well. So I think I'm going to need to rethink my adhesive spray for the base plate. Well, that's turned out really nicely. The belt holder is a beautiful snug fit around the linear bearing here, and I've managed to get the belt a little bit tighter, so great outcome. Next up, I'm going to install this belt tensioner, and this should do something about the slackness of the belt and tighten the whole thing up. Now have a look at this. This is not good. So I have been very carefully monitoring the temperature of the high current connections on the control board, and I did find that one of them was warming up somewhat. And on closer inspection, you'll be able to see the reason why. It's because this solder joint on both of the terminals has completely cracked all the way around, so that the terminal block can sway from side to side on the other side of the board. Now it turns out that the 3D printer was able to continue working because even though the solder joint is cracked, it's still got electrical contact, so current is still flowing, but there's enough resistance there so that a certain amount of heat is being generated, which of course could lead to a fire. So given that I'm now aware of this problem, the solution is of course to just reflow the joint with a really big blob of solder. but it's very concerning that this can happen on this board. Well, welcome back. So a couple of weeks have passed, and in that time I have been running the 3D printer almost continuously, day and night. And according to the status screen here, it has been operating for 6 days, 20 hours. And in that time it has got through 794 meters of filament, which feels like quite a bit to me. And in that time I have been mostly printing out upgrade components for the printer itself. So let's have a quick look through what I've actually added to it. So in addition to the X belt holder and the tensioner, I have also added a tensioner for the Y belt, tighten that Y belt up. I have added a T-frame support, and this stops the frame from swaying from side to side. It reinforces in that direction. Now, several other parts like this had to be redesigned a little bit because the wood frame in my replacement frame kit is a little bit thinner than the acrylic in the standard kit. So yeah, that was a bit of an issue. In addition to the T-frame support, I also printed out this semicircular fan duct, and this replaces the stock fan duct and does a bit of a better job at guiding cooling air to the plastic as it comes out. Then I have these two filament guides here and here. These help reduce the friction so that the filament can enter the extruder more easily, and it helps make the flow rate a little bit more consistent because the tension remains a little bit more constant. Anyway, so these parts made the greatest improvement to the print output quality. Then in addition to these things, I also added a Y end stop holder. This is needed because the mountings in the replacement frame for the micro switch didn't fit the switches from my kit, so I need to make something custom to put that in the right place. Then I added a cover for the filament release button. This is to save your finger because in the stock design there's just a bolt head that you have to press your finger down against a spring to release the filament, and this really hurts when you do it. So having a nice cover over the top of that bolt makes it much more comfortable to use. And then you'll be able to see I've got these cable chains for the X and Y axis. Now these protect the cables from being damaged by the moving parts, and they're also quite cosmetically appealing. I really like the way they look on this thing. Then I had a few problems to solve with the LCD mounting, and the replacement frame didn't have any mounting holes for the LCD, and I didn't really want to drill any. So I printed out a mounting frame and hot melt glued it in place. So that's all fitting quite nicely. And also the button holes are slightly oversized, which means the buttons can move from side to side when you press them. So I printed this bit of trim that makes them fit more snugly. And then finally I have this cover for the electronics, and then a frame that lines the electronics up with the mounting holes that are on this replacement frame. So that's a lot of upgrades, and I still have a few things I'd still like to add to it. But just with these things, I've got a huge improvement in both the construction and the output quality of this printer. I'm very happy with what I have so far. So after installing all these upgrades, it will be interesting to see what, if any, difference it's made to the output quality. So let's get this cube under the microscope and we'll see what it looks like. So here I've got the old cube on the left and the new cube on the right. And the differences between these two are quite minimal, but there is something to see here. Now, if we look at the Z faces, these are completely similar, and the output quality is very consistent. Now, if we flip over to the X face here, in the old cube, you'll be able to see these ripples that cover the X face here. And in the new cube, there are still ripples there, but they're certainly a lot less extensive and cover a lot less of the face. And similarly on the Y face, if we have a look at the old cube, you can see that the face is quite covered in those ripples, and there are still those ripples there in the new face, but they have been somewhat reduced in extent, so that's a good outcome. But unfortunately in this new cube I still do have a problem with it having missed a step here, and that's unfortunate really, because I haven't noticed it doing that ever so much since the belt's been tensioned, but clearly it still will do that sometimes, skipping steps, and that's really unfortunate that it might do that. So I have got some improvements from my upgrades, but it's still not perfect. But from my experience, it is workable. Now for my bed adhesive, I've settled on using the old hairspray trick. So I've got a can of Anet hairspray. This is the really cheap stuff. And what you do with this is you just spray it on really thickly. And you basically need to spray enough of it on so that it forms a smooth surface. So you don't want to do a light spray. You want to form a small lake on top of here. And try and get it nice and even. And then we will leave that to dry for an hour or two, and then once it's all evaporated, we'll come back and put another layer of hairspray on there. Now if we have a look at the ingredients list on the back of the bottle, we can get an idea of how this spray actually works. And the main ingredient that really matters is this neodecanoate copolymer, and this is dissolved in water and alcohol. So when you spray out the hairspray onto the glass, you get this solution, and then the water and the alcohol evaporates away, leaving you with a thin layer of this polymer on the surface of the glass. Now this polymer has a very low melting point, so when the print head comes along on the first layer and squirts a bit of hot plastic into it, the polymer melts into a liquid but then solidifies, so you get that phase change. And with the solidified hairspray polymer, that then holds the first layer of plastic in place until further layers are printed on top by the print head. So it's a very simple trick, but it works really, really nicely. So if you're looking for a hairspray brand in whatever country you're in, you just want to find one that's pretty cheap, unscented ideally, and just find one that's using this copolymer trick, and then it should work fine. Now a single application of the hairspray should be good for at least a dozen prints, and then when you want to reapply it, you can just wash it off with warm water, and all being well, when your prints are finished, the item should just pop off nicely at the end. So anyway, now I'm moving on to the next test, and this time I'm printing a benchy. And for those that don't know, a benchy is basically a small toy boat that you can print out, but the model is very specifically designed to really torture test the printer, and it has a few features in it that are specifically designed to expose any particular problems that your printer might have. So let's get this thing printed, and then we can have a look at the quality of the results. So here we have it, my little benchy is all printed out, and at the superficial level this thing is looking really, really good. I'm really, really happy with the outcome of this thing. Now of course when we get this under the microscope we'll be able to see all the imperfections, but just at this level I'm really happy with what this printer's giving me. It looks great. So as I say, this is a pretty good benchy, and overall there's a lot to be happy about here, but of course there are one or two imperfections. The first thing is that you might notice there's a bit of dripping, there's a string coming from the chimney here, and if we look at these holes near the bow as well, there's a little bit of deposit that's accumulated here due to dripping, and that basically happens when the print head moves location and it drags away a little spider web of plastic as it moves. And again, this is not ideal, but it's pretty easy to fix this with a scalpel. You can just cut this stuff away. And similarly, you might be able to see there are a few little blobs along the bow here, so those can be cleaned off with sandpaper. It would be nice if I can find a way of stopping it from doing that. Also, if we have a look at the front windscreen hole here, you can see this is a really hard test, this top edge here, because when the print head comes along it has to just deposit plastic in thin air, and of course we do have a bit of sagging here. It's not quite square, but all things considered that's not a bad arch at all. And again, as we look at these vertical arches here, the same phenomenon occurs. It's difficult for the printer to print a vertical circle, and the same here too. But again, you know, I'm not unhappy with what's going on here. It hasn't completely fallen to bits or anything like that. Now there is some things that have come out quite well. It's not that visible on this microscope, but let me see if I can get this in focus. So on the back of it we are expecting to get the text 3D benchy, and At the resolution I've printed this thing at, that text has come out just about as well as I would expect. Now on the base there is a really harsh test of the printer. You can see this text which is sunken into the bottom surface, and this is really hard to print because again the printer has to come along and print a ceiling. And all things considered, I think this has come out quite well, but probably this is the worst looking feature of the boat that we have. Also, one other thing I noticed is that we seem to have a weird looking bulge along the bow here, so I'm not exactly sure what's going on there, what caused that. But other than that, this is a really good benchy, and overall I'm pretty happy with the results. Certainly for my needs, with a bit of sandpaper and a bit of filing and scalpeling, whatever it prints, I can muscle it into being the dimensions that I need it to be. So let's have a look inside this power supply. I'm certainly not expecting great things. It will have been built down to a price, but the question is it safe and will it burn your house down? So let's get the lid off and have a look inside. There we go. Now, one of the things I noticed right off the bat is that when you mount this power supply on the side of the 3D printer, you have to screw into some holes which are on the bottom of this back plate here. And then on the other side of the plate, you have the power supply board. Now, when you screw in, if your screws protrude through the back plate here, they're going to head towards the surface of the board. And the only thing preventing your screw from making contact with the board's surface is a really, really thin layer of like plastic material or acetate or whatever it is, and that is all that prevents you from touching your screw head onto potentially live voltages on the PCB. So I really don't like that at all, and I am going to take very great care to make sure that I use the shortest screws that I can so that my screw heads are absolutely nowhere near the circuit board. I don't want to short anything out, and I don't want to have a live screw head coming out the top here. Now ideally we'd have some quality brand capacitors in this thing, something like Nippon Chemicon or Rubicon, but of course it's far too cheap for that. So what exactly do we have installed in this thing? As I tilt it round, you can see we've got Rubicon. I like it. Now let's have a look at the reverse side of the board. So we've got the high voltage live mains coming in round this way to the main switching FETs. We've got some control circuitry in here, and we've got the low voltage high current output path over here. And it looks all right, I guess. We've got a slot here, an isolation slot between live and low voltage stuff, so that's good to see. But something I don't like is the way the through hole pins have been bent over, and they're heading towards all these adjacent tracks, and that doesn't look very good to me. I can easily imagine with these high voltage ones you could end up with a short here, so that's not good. The other thing I'm a bit suspicious of is this earth track round here, and basically the way it works is that the chassis screws in through this hole, and so the idea is that because the bolt will end up making contact with these pads here, it will end up earthing the whole chassis, which is fine in principle, but I can easily see this getting quite worn away and contact becoming a bit intermittent. So I'm suspicious of this. It seems like an awful lot of trust to earth the chassis just off this one tiny little pad. So I'm a bit worried about that. So overall, I'm pretty unhappy with this power supply. The main problem, I think, is that mounting hole issue. You really don't want to end up putting live voltage up into the bolt heads. So that's a major problem, and I think that's reason enough to upgrade the power supply. I think that's something you're going to need to do if you order one of these, because you need to have a power supply in there that passes some kind of legitimate safety specification. Now I want to be able to control the 3D printer remotely. I don't want to have it on my desk making noise attached to my PC giving me a headache all the time. I'd like to have it stashed away in a corner, somewhere quiet where I can leave it doing its thing. And so to do that, I've got this Orange Pi, and the Orange Pi is quite similar to the Raspberry Pi. It's a similar form factor, and you can buy these on AliExpress. They're even a bit cheaper. This is available for $18.88, And inside this thing we have the all-winner H3 processor, which is an ARM-based processor. So I've been wanting to do a little project with the Orange Pi for a little while, so I'm going to install Debian Stable on this thing, and then we will install Octoprint, which will do the remote control of the 3D printer. Okay, so I've got my Orange Pi all set up now. Now the first thing is that I need an enclosure for this thing, but that's no problem at all when you've got a 3D printer, because you can just print one out, and that's exactly what I've done. Then on the software side, I've got Octoprint installed, and Octoprint is basically a simple web-based GUI for controlling 3D printers. It allows you to upload print jobs and monitor the printer status. And I've set it up so that I can access it through the open internet. So I can just go to octoprint.airwebreathe.org.uk anywhere in the world, and I can monitor the status of the printer, which is going to be really useful because it means that I can keep an eye on what the printer's doing and how much progress it's made, even if I'm out of the house. Now, I'm not going to spend too much time talking about how I installed this thing, because that would be a bit boring, but I do just want to talk briefly about how the network architecture of this thing is done. So let's have a quick look at how that works. So in my setup, I want to use my hosting service as a proxy between the internet and my Octoprint on the Orange Pi on my local network. And I'm using DigitalOcean. They're not paying me to promote them. I've been using them for a couple of years, and I'd say they're a great value service. I pay $5 a month per virtual private server, and these servers are just complete free Linux environments. You can run really any flavor of Linux you want to, and you can install any software that you want without any limitations at all. So as far as I'm concerned, they offer a really good service at a great price. And I've been using one of these droplets to run my website and a few other services that I make use of. So I've already got an instance of Nginx deployed for my web hosting. So for me, it's not very hard to use this as a front end, so that I can use this to give me also the SSL service. And I use Let's Encrypt for free SSL certificates. Now, of course, the bane of any home network setup is the NAT that's in the router modem that you'll have. And, of course, one way of traversing between your local home network and the internet is to just set up port forwards. But, of course, oftentimes you'll be on a dynamic IP address, so your IP address will tend to hop around, which makes things a bit more difficult. And there are various solutions to this. The solution I've chosen is that I've got my Orange Pi to set up a long-running SSH connection up to the DigitalOcean droplet, and this is just this connection is kept open continuously. Now, SSH is usually used for remote shell sessions where you can type commands in through the terminal, but in this case I'm not using that aspect of SSH. Instead, I'm using the tunneling facility that it has, and so through this connection that's going up to the droplet, I can open up a tunnel from port 5000 on the local host of the droplet to port 5000 on the local host of the Orange Pi. So a connection that appears over here gets teleported over here. But the backbone of this is an outgoing connection that goes up to the droplet, so no problems with NAT traversal. So with this, it means that I can run Octoprint on the local host on port 5000, and then Nginx can just proxy through to it via the tunnel through this SSH session. And it seems to be working very nicely. Now, to protect myself from my 3D printer getting hacked, I've got a password on this, and then, of course, the SSH session is encrypted, and the HTTP session is encrypted with SSL up until Nginx. So the whole thing's encrypted all the way between Octoprint over here and the browser on the end of this connection over here. So I've got it all set up, and it's working really, really nicely. Now, if anyone's interested in replicating the setup in any way, I'll put a few of the config files up in the show notes. So I've spent quite a bit of time with this 3D printer by now, and I would say that I'm in quite a good position to give a pretty rounded review of this thing. So on the good side, it is very low cost. You can get it for $170 or $180 depending on what kind of deal you can get. And that price is so amazingly good that really there doesn't need to be a barrier to entry to 3D printing for anyone who wants to participate, which is wonderful. And in addition to this, there is a great community of people. A lot of people are using this 3D printer online, so there's lots of advice, and there's lots of options to upgrade the printer, objects you can print out and all that kind of thing. And on the whole, I'm getting really good print quality outputs, so I'm really happy with that. And as someone who's new to 3D printing, I think I'm going to get a lot of useful use out of this thing. And also, I've got a completely open source software solution, which is always the goal on this channel, and I'm really happy about that too. But on the bad side, the community, they kind of talk like people who are recovering from domestic abuse or something of that nature. And there are good reasons for that, because almost every aspect of this printer has been built down to the minimum quality. And in some cases, the quality is below what's viable, and never more the case than in the situation of the electrical safety, which is a real problem. And people who are buying this printer shouldn't have to think about this electrical safety stuff. They should just be able to plug it in and trust that it's going to be safe and not cause an accident. But unless you have some expertise with electronics and you can solve the various problems that it has, you're not going to be able to do anything about those problems, which is not how it should be. And a lot of this stuff with the electrical safety it's not that they were saving money, it's just that these things just haven't been done quite right, which is frustrating because they could have done these things right and kept the price low, if you see what I mean. And that goes for a lot of things, like the acrylic frame. Acrylic is not a good material for a frame, and even people who didn't use Loctite have reported problems with cracking and warping of the frame. And there are a lot of aspects of the design that are very similar to this, that they just don't quite work out well enough to deliver a quality product. Now, a lot of the time you can deal with these problems just by upgrading and replacing various components, but then of course you're having to spend additional money. So suddenly that $170 purchase price isn't looking so good, because you might have to spend $100 more just to get all the upgrades in place. And in fact, in my printer, there isn't that much left of the original kit. I mean, there's some poles, some screws, the plate, and the motors, but I'd want to replace the power supply. I'd probably want to replace the main control board. I'll probably replace the extruder, and all the plastic parts I could reprint. So by the time I've done that, there's going to be, I feel like I will have replaced 2/3 of the printer or more. So I'm sure there are other ways to get a 3D printer, and in fact from the little research I've done, I think there are quite a few different options for printers that are available in the sub $200 price range that don't suffer from any of these problems. So I'd encourage you to shop around, and unfortunately I can't give this printer a thumbs up because of these problems. But despite having said all that, I do have a working 3D printer, and I am going to be using it, and I am getting good results from it. So it's kind of a mixed bag. And overall I'm happy with the outcome, but it was quite painful and difficult to get to this point. So that just about wraps it up for this video. Thank you very much for watching, and I just want to thank Adrian Ebeling. He is the very first participant in my brand new Patreon, and it will help support the channel, help it to be supplied with equipment and things to test in upcoming videos. And I'm very grateful to everyone who's getting involved with the channel, so I will see you all next time on the Open Tech Lab.